Hey guys, Mr. Riz here, and we are going to start the first section of Chapter 2. And Chapter 2 is all going to be about quadratic equations. So we're not just focusing on like domains and ranges and just all types of graphs. We're going to get into more detail with one specific type of graph or one specific type of function, which are the quadratics. So you guys have probably worked with quadratics before, but in this class, what we're going to do is make sure we understand the ins and outs of them. So we want to make sure today, after this first part here, we can identify the key features of all quadratic functions. We're going to spend 2 days on this first section, and so we're going to just take our time with that at the beginning here. Just do some warm-up stuff. So a function is a quadratic function if its equation can be written in the form f of x equals ax squared plus bx plus c. That might look pretty familiar. You guys probably used the quadratic equation before and see that. Now, all quadratic functions are transformations of the parent function defined by f of x equals x squared. So remember, they make the U-shaped parabola. This graph of the quadratic is called a parabola. The vertex form of the equation is, and this is what we're going to focus on, f of x equals a times x minus h squared plus k, where the point hk is the vertex of the parabola. Vertex form is useful because it highlights the vertex of the graph and the quadratic function. So just to let you guys know, if you guys remember, like when we did lines, like you can have a lot of different lines. You can have like 2x plus y equals 3, but it was always a lot easier to graph something in y equals mx plus b. When we're working with parabolas, it's going to be a lot easier to graph if we use it in vertex form. So this next part, I'm going to use a slider on Desmos just to kind of show you guys the transformations that will happen. So let me split screen the notes here, and I have moved my face here. I have the parent function graph in black, and I actually have the original function over here. Now the parent function, if we want this to match this equation here, a would have to be 1, h would have to be 0 to just make this a plain old x inside here, and then k would have to be 0. Now we kind of know if I were to adjust some things, like if I were to change k, make it negative numbers, the graph would shift down. If I'd make k positive, it would shift up. And let me try to go back to 0. Oh, well, I'll make it down to -1. And then h, if I make h positive, we subtract a big number, it moves to the right, moves to the left. Now what we're going to kind of focus on is this a number here. What does that do? So if I increase a, it makes the graph skinnier. And now if I make it a fraction, it makes it wider. But what the big point here is once a becomes negative, it flips over the x-axis. So if we want to look at the transformation of, if we have the original function x squared and how it affects, if I have a -1/2, and I could probably type that in for a, -1/2. Oh, I have -1/2. Oh, -1/2. And let's see, h would be +2. So I'd have to make this -2. And then k, there is no k at the end, so I'm going to just make k equal to 0. We can look at that graph. We can kind of determine the transformation of this graph. It's move over to the left 2, and it's reflected over the x-axis, and it's actually stretched out a little bit. So let's go ahead and see if we can determine these transformations just from the graph. And so we actually did this in the last chapter, but we're just kind of going over it again to review the concepts here. And we'll double check it on Desmos here. So if I have g of x equals -x minus 2 squared. All right, so nothing is being moved on the outside, so this isn't going to be shift up or down. We have a +2 on the inside, so that means it's going to be to the left 2. And it's going to be reflected over the x. And just double check that on Desmos here. If I was to make a, the number on the outside of the parentheses, just a negative sign, that'd have to be a -1. Let's see, h would be -2, so that's how we get a +2. And okay, if we look, yep, it just moved over to the left 2 and flipped upside down. The shape is still the same shape, it's just upside down. All right, we got another one here. Let's look at this and see how that transformation happens. Okay, so we could drag this up to set this up if we want to, or what we can do here is we should know from last chapter what type of transformations it's going to happen. This +2 on the outside means the graph is going to go up 2, And then this -1, it's going to go to the right one. So let's just double check that. So there's no number on the outside. Well, technically there is a 1, a positive 1 on the outside. So we'll make a equal +1. X minus h, h would be a +1 if it's minus +1, and then k would be a +2. And so look, that graph did the same thing, it's just moved up to right 1. Okay. Hopefully we're feeling all right with this and we can move on to the next part. I'm going to full screen this here. Okay, so what we're going to do now is to identify some of the key features of the quadratic equation. So this is not just going to be domains and ranges, but really what's going to happen into the graph. The first key feature is the vertex. So if you want to make some notes, it's written right here, but maybe you need to highlight it so you know, is that the vertex, which is the point of the graph here, where the graph shifts from decreasing or increasing, or if it was flipped upside down, from increasing to decreasing. The vertex is going to be located at the point h comma k. So if we look back at this equation over here, this number is a, 2 is a, 3 is h, 4 is k. The vertex would be hk, so this would be at 3, 4, which it is right here on the graph. Now we can determine based off of the graph just visually, or we can determine whether that vertex is known as a minimum point, which it is in this graph here, or if we had it flipped the other way, if it was flipped like this, this would be a maximum point. This is the tallest part of the graph, would be a max. Determining if our A is positive or negative. So we'll make another point. So if A is positive, then the vertex is the max. And then else, we can put here if, A is negative, and the vertex is a min. Oh, I have that backwards. Oh, all right, Riz. Good morning, waking up. All right, if A is positive like this one, if A is positive, the vertex is a minimum. And if A is negative, we are a maximum. Okay, and the last thing that we need to talk about is the axis of symmetry. The axis of symmetry is the reflection point where the graph is even across. So we can see like this point that's 1 away is up to 1 away. This one would be up to 1 away as well. So all these points get reflected over this axis of symmetry. The axis of symmetry, AOS, axis of symmetry, is going to follow the equation. And in this chapter, it's always going to follow this way. Now later on, we'll learn about conic sections and we'll introduce parabolas again. So this might switch around. But it's always going to be x equals whatever our h number is. Okay. So what we're going to do on this, we're always going to try to figure these out algebraically. We're going to try to do this in our head. But we're going to use Desmos to double check some things. So let me go ahead. Let me clear off this. Hopefully we have our notes. You have it written down. Remember, you can always pause the video if you want. I'm going to go ahead and we're going to figure out, we're not going to do domain and range. So you guys can cross that off. I've already determined we've drilled and killed this part, domain and range. It's not going to be on the CYU. You guys just need to tell me the vertex, axis of symmetry, and whether that vertex was a min or a maximum. All right, so let's look at this. The vertex, which is at HK. So remember, it's H is the minus number in here. So this would actually be at -4, comma, and then K is a -5, -5. So the vertex is at -4, -5. The axis of symmetry is going to be X equals whatever the H number is, -4. And then we determine whether this vertex is a min or a max by looking at the A. The A is a -1. That's a negative number. So this would be a maximum point. Okay, so let's double check this by looking at Desmos here. I'm going to use the slider here. I could just type this equation in, but I'm going to use the slider just to kind of help us out here. A is -1. H would be -1 as well, or -4. and then k is -5. And if we look here, there's the graph. We have the maximum point or the vertex at -4, -5, and that is a maximum. And if we were to draw the line here of x equals -4, it does cut that graph right in half. Okay, so let's keep this going, make sure we can handle this information here. Okay, next thing that we're going to do here is write the equation based off of this information. And to write the equation, what we're going to do first is just given one point or the vertex and another point on the graph. So the equation, this is kind of like when we did y equals mx plus b. So if I have the equation y equals a times x minus h squared plus k, I need to find three things. When you guys did y equals mx plus b, you had to find m and b. When you find a parabola, you have to find three things, a, h, and k. Well, the easiest one to find is h and k because they're from the vertex. So I could set up this problem as y equals a times x minus -2 or plus -2, or plus +2, I should say, and then plus 3. The problem is now we still need to figure out this a. Well, in order to find a, we can actually do like what we did to find b when we did y equals mx plus b. We can use a point. Now they get real fancy in this first example and say the point is the y-intercept at -1. Really, this is a point at 0, -1, meaning our x is 0 and our y would be -1. I'm going to go ahead and replace our x and y with those numbers to solve for a. So let's see, this would be -1 equals a times x is 0 plus 2 squared plus 3. And let's do some math here. We have to add these together first. So a equals 2 squared plus 3. We'll square that number. So we get 4a plus 3. And we're just going to solve for a. I'm going to minus the 3 over. So -4 equals 4a. And so that means a would equal -1. So that means the equation that would have this vertex and go through the y-intercept at -1 would be plugging in our a, h, and k. Y equals a is -1, x minus h is -2, so it becomes +2. On the CYUs, you guys would put minus -2, and then plus k is 3. And so there's your answer. All right, so if we want to go ahead and double check this here, we have that example right there. So let's try to do this one together. Now, if you want to pause the video and try it on your own, I would recommend that. And let's go through this. So we have a vertex. Here's our h and k. We have a point here. It's not written anything fancy. This is just our x and our y. So we got to find h, k, and a in our equation. Y equals a times x minus h squared plus k. You guys are going to have to pretty much memorize that by the end of the chapter. Okay, so we don't know a, but we do know h and k. So we have to find a. So we're going to use x, y, h, and k all in this formula to figure out what a is. All right, y is -1. A, we don't know. We're going to figure that out, so we'll leave that as a. X is -2 minus h is -1, or is 1, so -1 squared plus k is -4. All right, so let's start to simplify this. Let's do the inside here. -2 minus 1, that is a -3 squared, and -4 over here. All right, let's square that a. So this would be 9a minus 4. We're going to go ahead and add that 4 over to the -1. So 3 equals 9a. And so we'll divide by 9. 3 divided by 9 is 1/3. So that means our equation would be y equals a, which is 1/3. And then we'd have x minus h is 1 squared plus k, which is plus a -4, just -4. There's our answer. Okay. Clear all my drawings. Okay, the next part here. So once again, okay. Write the quadratic and then in the form. Okay, we're actually gonna stop here because we'll start this with part 2. So I wanna go ahead, and I've been told this next chapter, I should probably help you guys out with some of the CYU problems. So that's what I'm going to do next. I'm gonna go ahead, I'm in the wrong class here. I'm gonna open up the CYU and show you guys what you guys are gonna be working on. Chapter 2, CYU 1. Okay, so if you look at these problems here, they're all very similar. The first type of problem is you're gonna find the vertex, determine whether the vertex was a min or max, and find the axis of symmetry. So let's just go ahead, I don't know, we'll do the first one. All right, so we look at these, our A number is 1, H is 2, and K is 3. So this vertex would be at the point 2, 3. Is that vertex a min or a max? Well, A is positive if A, because it's technically positive 1 here. If it's ever positive, it is a min. And our axis of symmetry is 8. X equals whatever our H number is, 2. So that should help you guys out with those types of problems. And then the next types of problems down here is find the equation of the parabola. Undo the one with all the negatives here. You guys can mess around with the decimals or the vertexes. You'll be fine. Unsplit the difference, undo the medium one. Okay, so what we have, the vertex is H and K. I'm not sure if you guys can see this, it's pretty small. Try to zoom in. All right, so the vertex tells us H and K, and the point tells us X and Y. We need to still figure out what the A number is here. So let's go ahead. I mean, you should be able to figure out that this is going to be a -4 minus -24. The question is, what is this A number in front? And in order to get that, we have to fill out the formula. So we have Y, which is -25, equals A, we don't know, times X, which is -5, minus H, which is -4, squared plus K, -24. Let's go ahead and start to simplify this. All right, A times, if I have -5 minus a -4, that'd be -5 plus 4, which is -1. And I got a -24 here. All right, what happens if I take -1 squared it as +1 and times it by A? That's just a regular 1A, or just A minus 24. And we can add that 24 over to the 25, and so A would equal -1. So this should be a -1 times X minus -4 plus a -24, if we're just typing this into Canvas. Okay, hopefully that helps you guys out, and we will start the next section and finish this, our next part tomorrow to finish the section. I'll see you guys then.